we're discussing about the theoretical distributions on probability, that we have seen the random variable, how the probability of 1 can be distributed to the different elements of the sample space, and after that we have seen the binomial distribution also, and I have briefly explained you how the Poisson distribution will be, because it will be useful for your board examination. And as far as IIT syllabus is concerned, I told you that we have up to binomial distribution only, and we worked out a problem, interesting problem also yesterday, which is based on the umbrella seller, and we have seen his average profit to be 600. Okay, now let us work out a few more problems on the same, and then we will go for the mixed problems. If you see the next problem, please go to the slide. 4 bad apples are mixed accidentally with 20 good apples. So how do you see that? How many total number of apples are there? 24 apples are there. Among 24 apples, you have 20 good apples and 4 bad apples. Probability distribution of the number of bad apples in a draw of 2 apples with replacement is formed. Then the mean of it is how many apples are there totally? 24 apples are there. How many are good apples? 20 are good apples. How many bad apples are there? 4 are bad apples. And probability distribution of the number of bad apples in a draw of 2 apples. 2 apples are drawn from 24 apples, and we need the probability distribution of the number of bad apples. If you draw 2 apples from 24 apples, these two apples may be good apples. That means 0 good apples, 0 bad apples. If both are good, 0 bad apples. If one is good, one is bad, or both are bad. So how many possibilities are there? If you draw 2 apples from 24 apples, which is consisting of 20 good and 4 bad apples, the random variable in that case will be 0 bad apples. That means you are getting both the apples good, and 1 bad apple. That means other apple is good, or both the apples bad. So how many variables are there? Random variable is here 0 bad apples, 1 bad apple, and 2 bad apples. And now you have to write the probability of this random variable. Now we need probability of x equal to 0. X equal to 0 means you should not get any bad apple. That means you must get both the apples good. So how many good apples are there? 20 are there. 20 C2. How many total number of apples are there? 24 C2. It's the total number of apples, and these are the 2 good apples. Now in this case, 1 good apple and 1 bad apple. That means 1 good apple 20 C1 and 1 bad apple 4 C1 upon 24 C2. 1 good, 1 bad, both bad, 4 C2 upon 24 C2. This is the probability distribution, understand that. But we need the mean of it is. The mean of it is nothing but the mean mu is given by sigma x into p of x. Of course, this is 0, and this is to be simplified. And one more cross check for you whenever you prepare the table. Understand the sum of the probabilities must be 1. If it is not going 1, understand that you're gone wrong somewhere. So if you add this, the denominator is 24 C2. 24 C2, we are adding all this. 24 C2 is nothing but 12 into 23. Mind calculation. 24 C2 means suffix is 2. Start from 24 and write 2 factors in the descending order. 24 into 23 upon 2, the 2 gets cancelled. It is 12. It is 12, and the numerator is 20 C2. It is nothing but 10 into 90. It is nothing but 190. Plus it is 20 into 4. It is 80. It is 4 C2. It is 4 C2 is nothing but 4 into 3 upon 2 is nothing but 6. So totally it is 6, 8, 9, 7, 17. That is 276 upon 12 3s are 36, 12s are 24, 26. This is 1. Understand that? So what the table we have prepared is correct, because the sum of the probabilities we have got it to be 1. You can cross check like that if you prepare such a table. If you're not getting 1, means you've gone somewhere wrong. Understand, while working out this type of problems. Now mean is simply got by 0 into this becomes 0, and 1 into this. 1 into this is nothing but, we have just now calculated 80 upon 12 into 23, plus it is 2 into 6, it is 12 upon 12 into 23. 80 plus 12, it is 92 upon 12 into 23. If you simplify this, you'll get the answer. Okay, that's all simplification. Preparing the table is important here. If you simplify this, you'll be getting the answer. If you want the answer, this goes for 6, can be, this is 6 times, let me say, this is 4, 6, 46, 3 times 23, 23 getting cancelled. So what should be the answer here now? 92, 23 getting cancelled, 92, it is 1 by 3 is the answer. You can check the answer. Answer is 1 by 3. Okay, let's see another problem. Next, let X be a binomial distributed variate with mean 10 and variance 5. Mean 10 and variance 5. Understand, mean is 10 and variance is 5. And yesterday we have discussed the mean is NP. And mean is NP, it is given to be 10, and variance means it is NPQ, it is given to be 5. Then if you divide, this is 1, let me say, this is 2, let me say, which implies 2 divided by 1 is, Q remains, Q is 1 by 2. If Q is 1 by 2, P is also 1 by 2, and implies N is equal to, if you substitute P 1 by 2 there, N is 20. N is 20. That's what is given. Now we need the probability of X greater than 10, please. Greater than 10 means what? Greater than 10 means it starts from 11. 11 to 20. You have to write 11 to 20. You have to write all of them. 11 to 20 means you will be getting 10 such type of probabilities. So to write that, we make use of the summation sigma. Sigma, we write the general term now. General term will be taken to be, what is the probability of X successes? You know, it is NC X into Q power N minus X into P power X is the formula. So how many number of tiles are here? 20 C, and here it may be 11, 12, 13, 14, 15, 16, so on like that. So what we do here, it is given to be K, and K runs from 11 because greater than 10 to 20. 10 to 20. And you can see that P and Q are same value. P and Q have same value. That is 1 by 2. So 1 by 2 whole power N minus X plus X. N minus X plus X is N only. This is half whole power. N is 20. You can see the option there. It is sigma 20 CK. Sigma 20 CK into 1 by 2 whole power 20. And K runs from 11 to 20. Which one should be the option there? It is option number 1. Option number 1 is the correct answer for this one. Understand, the binomial distribution is application of binomial distribution. I hope you understand this. Okay. Go to the next problem. X follows a binomial distribution with parameters n is equal to 8 and p is equal to 1 by 2. Then p of modulus of x minus 4 less than 2. Yes, because the absolute value is used here. Absolute value is used here. That is why I have taken this problem. N is clearly given to be nothing great in this problem except that modulus is to be properly used. N is given to be 8 and P is given to be what? It's 1 by 2. Obviously Q also 1 by 2. And what do we need is probability of modulus of x minus 4 is less than or equal to 2 is there. Probability of modulus of x minus 4 is less than or equal to 2 is there. What does it mean? Modulus of x minus 4 less than or equal to 2 means minus 2 less than or equal to x minus 4. You can write capital X or small x, whatever you like. It is less than or equal to 2. Modulus means less than or equal to 2 means its value lies between minus 2 plus 2. And if you rearrange this is 4 minus 2 less than or equal to x is less than or equal to 2 plus 4, 6. So you have to write this now 2 less than or equal to x less than or equal to 6. How do you understand this? This is p of 2 plus p of 3 plus p of 4 plus p of 5 plus p of 6. You have to sum all these probabilities. Now what is end in this case? 8 HC2, because P and Q have the same value. P and Q have the same value. This is 8C2 plus 8C3 plus 8C4 plus 8C5 plus 8C6 into 1 by 2 whole power 8, because P and Q are same. If you simplify this, you'll get the answer. This is also an important model to be understood. Okay, next problem please. Next problem. Out of 100 families with 4 children, out of 100 families with 4 children each, out of 100 families with 4 children each, the number of families all of whose children are daughters. It's also an interesting problem. 10,000 families we have taken with 4 children each. 4 children each. And the number of families all of whose children are daughters. So in this case now we have to get the success to get all the daughters. All the 4 must be daughters. What is the probability to get a daughter? It's like a head and tail on a coin. Either a boy or a girl are taken. Either a boy or a girl is taken. So how many outcomes are considered? Only 2 outcomes are considered in this case. To have a daughter, the probability is 1 by 2. To have a son is also 1 by 2, like getting a head or tail on a coin. So in this case now P is equal to Q is equal to 1 by 2. So getting a daughter, the probability in one trial is 1 by 2, and as well the son that is not a daughter is nothing but 1 by 2. So it is nothing but NC4. N means each family has 4 children, so it is 4C4 into 1 by 2 whole power 4 minus 4, that is 0 into 1 by 2 whole power 4. You need not have to write that, because whenever both are equal, you can write only single term. It is 1 by 2 whole power 4. 4C4 is 1. It is 1 upon 16 is considering a single family consisting of 4 children, the probability to have all the daughters, getting all the heads if 4 coins are tossed, getting all the heads if 4 coins are tossed. 4 coins are tossed, or coin is tossed for 4 times, then it will be 1 by 16. So to have all the daughters, the probability is 1 by 16 for 10,000 families. This is for one family. The mathematical expectation for 10,000 families is 10,000 into 1 upon 16. 10,000 into 1 upon 16. So it is 6. And again 40. 40 means 2 times. 80 means 5 times. So 6,625 families. There is probability to have all the 4 daughters. All the 4 children are daughters. The number of families are chosen to be 10,000. Then among 625 families, there is possibility of to have all the 4 children daughters. That's one of the models, because we have got it only for, we have got the probability, we have counted the probability only for one family, and that one family is generalized to 10,000 families by simply multiplying this probability with 10,000. Understand that this is the mathematical expectation. Okay, next problem also same. 100 sets of 10 tosses of a perfect coin are taken. 100 sets of 10 tosses of a perfect coin. 10 tosses of a perfect coin means coin is taken, tossed for 10 times, tossed for 10 times. Like that, 100 sets are taken. Like that, 100 sets are taken. No confusion, please. We will write the probability only for 10 coins and then we multiply with 100 like this. We multiply with 100 like that to get the required probability. So, in how many sets approximately do you expect to get 8 heads at least? To get 8 heads at least. What does it mean? A coin is tossed. What is the probability of getting head and getting a tail? It's nothing but 1 by 2. How many times coin is tossed? 10 times coin is tossed. What is the probability you require? Probability of getting at least 8 heads. Go through that, please. 8 heads at least. At least means x is greater than or equal to 8, which should be probability of x equal to 8 plus probability of x equal to 9 plus probability of x equal to 10. You have to write all this. Now, in this case, it is, how many coins are there? 10 coins are there. It is 10C8 plus 10C9 plus 10C10 into P and Q are same. So, it is 1 by 2 whole power 10. It is for one set. It is for one set. So, for 100 sets, understand, you have to multiply this with 100. So, 100 upon 2 power 10 into 10C8 plus 10C9 plus 10C10 is 1. 10C8 is nothing but 10C2. Why 10C2? 10 minus 8 is 2. 10C2 is nothing but 9, 5 is 45 and 10C9 is nothing but 10C1. Difference 1. 10C1 is nothing but 10. 10C10 is 1. So, it is 55, 56. 100 into 56 upon 2 power 5 is 32. 32 into 32. If you simplify this, you will be getting approximate number of sets to get at least 8 heads. It should be 5. You can count that. Understand the method first. The simplification part, you can do that easily. The simplification part, you can do that easily. What we're doing here, we have taken a coin and we have tossed the coin for 10 times. And for 10 times, for one set, we have calculated the required probability, but we require this for 100 sets. For 100 sets, we are not applying the concept of probability. We are getting it for one set and we are generalizing this to 100 sets. Similarly, in the previous problem also, we have generalized it for 10,000 families. No confusion. No confusion, please. So, whenever 100 sets, like 10,000 families in the previous problem are given, you find out for one set and multiply that probability with 100. That thereby, you will not have any confusion. Okay. Now, let's see. This is also an interesting problem. A man takes a step forward. A man takes a step forward with probability 0.4 and backward with probability 0.6. The probability that at the end of 11 steps, he is just one step away from the starting point. He's just one step away from the starting point. So, let us suppose moving forward, if you take it as P, its probability is given to be 0.4 and moving backward is to be taken as 0.6 and the sum of these two, you can clearly see that it is 1. So, that is why it is taken. Forward is taken to be P and backward is taken to be 0.6. Now, how many steps he moved? He moved 11 steps totally. But what he needs is, let me say this is the starting point. From the starting point, he must be away one step from the starting point. Away from the starting point means he never mentioned any direction here. So, he may move in this direction or he may move in this direction. And requirement is he must be one step away from the starting point. He must be away from the starting point for 1 feet. So how is it possible if 11 steps are taken? This is possible only when he takes 6 forward steps and 5 backward steps. More 6 forward and 5 backward. Then what happens? He will be 1 step away from the starting point. Similarly, in this case, he moved 6 backward, because we are taking this direction as backward, and 5 steps forward. These are only the 2 options to have the person to be 1 step away from the starting point. Okay, now how many steps he has taken? 11 steps he has taken. Either this or this. That is why you have to add. What is that? We have taken it to be P here. Success. This is failure. Let me say, we have to apply the binomial distribution. Now, this is 11C forward, 6 into 5 steps backward. This is Q. So 0.6 whole power difference. N minus, you know the formula, please, all of you. Probability of x equal to x is success. X is nothing but NC x into Q power N minus x into P power x. Understand? NCx is nothing but 11C6. NCx, N minus x, 11 minus 6, 5. And P power, P is nothing but 0.4 whole power x. It's nothing but 6. Similarly, this side, 11C5 into, in this case also, it is 0.6, that is Q is whole power 6 steps backward, and 0.4 whole power 5. This is only the possibility to have the person 1 step away from the starting point. Now if you simplify this, what will you get here? This 0.6 whole power 5, 0.4 whole power 5, 0.4 whole power 5, 0.6 whole power 5. So we will take this 0.6 into 0.4 whole power 5 common. And within the brackets, you can understand it is very simple. 11C5 is same as 11C6. Why? The difference is 5. The difference is 6. Both are same only. So I will write it as, if you add them, it is 11C6 into, because both are same, I will take 11C5. If you understand, 11C5 common in both of this. We have taken this as common and 11C5 also common. Then what else is remaining here? 0.4 is remaining. What else is remaining here? 0.6 is remaining. This becomes, of course, 1. Of course, 1. Now this is 0.24 whole power 5 into 11C5. 11C5, you know, it is 11 into, right, 5 times, 10 into, 9 into, 8 into, 5 times, 7 upon 5 into 4 into 3 into 2. If you simplify this, you'll be getting the answer. So 0.24 whole power 5 is there already. In every option, you can find that. No. In the first and second options, you have 0.24 whole power 5. So it should be either 1 or 2. If you simplify this, you'll be getting this 5 into 2, 10 getting cancelled, and 4 into 3, this is 2 times, and 3 times, and it is 33 into 14, 33 into 14, 14 3 is 42, 43 is 42 plus 4, 48. It is 442 plus 4, 46. So it is 462 into 0.24 whole power 5 is the answer. For your better understanding, I simplified this. So this is how the binomial distribution can be applied. Okay, let's go to the next problem. The probability of a bomb hitting a bridge is 1/2. The probability of a bomb hitting a bridge is 1/2, and 2 direct hits are needed to destroy it. 2 direct hits are needed to destroy it. The least number of bombs required so that the probability of the bridge being destroyed is greater than 0.9. Little different problem. That is, he has given us the probability there the number of attempts not given, that is probability of x. What I said? The probability that least number of bombs required so that the probability of the bridge being destroyed is greater than 0.9. That is, it should be greater than 0.9. So how many bombs are required at least, or needed? How many bombs are needed? 2 direct hits are needed to destroy. 2 direct hits are needed means it should be x greater than or equal to 2. Understand? Probability of x greater than or equal to, that means it may be 2 bombs or 3 bombs or 4 bombs. Minimum of 2 bombs must be there. So if you write like that, 2, 3, 4, 5, 6, it will be lengthy for you to write the probability. That is why we come to the negation of that one. Negation means what? It should be 1 minus p of x less than 2 is greater than 0.9. Less than 2 means we don't want less than 2, we want at least a 2. That is why it is subtracted from 1. So which should be 1 minus, we don't know n there, we don't know n there. So n is taken to be n only, it is nc. Now I'll write for you better understanding like this. It should be p of x equal to 0 minus p of x equal to 1 is greater than 0.9. Now it should be like 1 minus p of x equal to 0, nc0, because n is not known to us, nc0 into what is the probability of hitting the bridge there, 1 by 2. Hitting the bridge is 1 by 2, not hitting the bridge is also 1 by 2. So both are same, it should be 1 by 2 whole power n minus, it is nc1 into 1 by 2 whole power n is greater than 0.9. So which is nothing but 1 minus, it is minus of, nc1 is n, this is 1, so 1 plus n upon 2 power n is greater than 0.9. And if you multiply throughout with minus, it is 1 plus n upon 2 power n is less than, this is minus 1, comes this side, it becomes minus 1 minus 0.9, it is nothing but 0.1. That means for what value of n this value is less than 0.1 is to be found out. If you write n is equal to 1, it should be 3 upon 2. Isn't it? 3, n is equal to 1, it is 2 upon 2, which is not less than 0.1. If you write n is equal to 2, it will be 3 upon 4, not less than 0.1. Like that, you can verify other, you have to make use of logarithms, otherwise not needed. From the options itself you can verify. So like that, if you write n is equal to 3, 4, 5, you can verify that. If you write 5, what happens? It will be 1 plus 6, 5, 1 plus 5, 6, 6 upon 2 power 5 is 32. So it is less than 0.1 only. So generally it n is equal to 5 will be satisfying. So how many minimum hits are needed to get the probability greater than 0.9 is n should be 5. That's the least number you require. Okay, let's go to the next one. Now, these are briefly about the theoretical distributions, problems on theoretical distributions. Then we'll be going to the mixed problems now. Mixed problems. Okay. Now, please, all of you, go through that slide there. It is Venn diagram. The Venn diagram, see how A intersection B bar is, and see how A intersection B is, and see how B intersection A bar is. What is the meaning of B intersection A bar? B only occurs, A does not. What is the meaning of A intersection B bar? A intersection or B complement? Only A occurs but not B. What is the meaning of A intersection B? Both A and B and stands for intersection occurs. So whenever you are getting confused with such type of notations, then better always follow the Venn diagrams. Venn diagrams. Like you can see that Venn diagram, and whatever is required, you can get it through the Venn diagram. You can easily understand through the Venn diagram. Please see that A bar intersection B bar there. What is A bar intersection B bar? A bar intersection B bar is what? Neither A occurs and nor B occurs. Neither A occurs and nor B occurs is nothing but the outside place of that circle. Outside place of that circle. Are you looking at the diagram there? A bar intersection B bar is what? Neither A occur and nor B occur means none of them occur. That means A bar intersection B bar is nothing but sample space minus A union B. Understand? What is the meaning of A union B? Either A or B or both occurs. It's the meaning of A union B is either A or B or both occurs. If it is subtracted from the sample space, neither of them occur. So understand that. If you apply probability to this, probability of A bar intersection B bar is equal to probability of S minus A union B is nothing but it can be written as probability of S minus probability of A union B. Probability of sample space is always 1 minus probability of A union B. Understand this. Neither of them occurs is equal to 1 minus at least probability of at least one of them occurs. Probability of neither of them occurs. Probability of neither of them occurs is equal to 1 minus probability of at least one of them occurs. Understand that? So, if you are getting doubt in simplifying this type of problems, always make use of Venn diagrams. That's why I want to show you that. Next slide, if you see, this one also, it is understanding through Venn diagrams. If you go through that carefully, 3 Venn diagrams are there, and you have sets and relations in your lower classes, in your 10th class itself. If you are CBSE student, you have sets and relations in 11th also. You might have studied all this in your lower classes itself. So A intersection B intersection C is nothing but occurrence of all the 3. That means A intersection B intersection C, A and B, the shaded region, A and B and C, all the 3 occur. What is the meaning of A intersection B bar intersection C bar? A intersection B bar intersection C bar. What is the meaning of it? Only A occurs but not B and C. Only A occurs but not B and C. What is the meaning of A intersection B intersection C bar? A and B occur but not C. Similarly, you can understand through the entire diagram. If you will find this type of notations in every book. You please go through them for the better understanding of these Venn diagrams. Okay, so that's what is given. P of A union B. First formula, please. P of A union B union C. Instead of union, we wrote there R, O R R, either A or B or C is given to be P of A plus P of B plus P of C minus P of A intersection B, because P of A intersection B will come twice. That is why it is subtracted. Minus P of B intersection C, that's also subtracted. Minus P of C intersection A, that's also subtracted. But that common area is to be added. That is the formula for P of A union B union C. Why it is finally added, why they are subtracted, if you see the diagram carefully, you can understand that easily. Instead of by hearting that, you can understand that easily through the Venn diagram. Similarly, P of at least 2 of the second formula, please. P of at least 2 of ABC occur. At least 2 of ABC occur means A and B, or B and C, or C and A must occur, and also AB and C also must occur. That's what is at least 2. At least 2 means 2 may occur or 3 may occur. For that one, you can see how it can be understood. P of B intersection C means both are occurring, plus P of C intersection A plus P of A intersection B minus twice of P intersection P of A intersection B intersection C. Minus twice. Why minus twice? It will be subtracted. That is why it will be subtracted, because that comes thrice. That comes thrice. So that is why minus 2 we will write. So that is at least the case. Similarly, you can understand P exactly 2 of ABC occur. Exactly 2 of ABC occur. How do you understand this? Exactly 2 of ABC occur means either A and B occur but not C, B and C occur but not A, C and A occur but not B. That's what is the meaning of it. So P of B intersection C plus P of C intersection A plus B of A intersection B minus thrice P of A intersection B intersection C, please. Like that you understand the problems through the Venn diagram. Please go forward. Yes, please see that one. This is mixed problems we are going to discuss now. Mixed problems, the probability, because concept wise when I am discussing the problems you may be feeling comfortable, but when you get the mixed problems from all the concepts, then if you get the idea which concept is to be applied or which formula is to be applied, then that will be the better way of learning. So we take the mixed problems now. The probability that a person will get an electric contract is 2 by 5. Let me say electric contract as E. Next, and the probability that he will not get plumbing contract is 4 by 7. Plumbing contract, not get, P of P bar or P complement is what? 4 by 5. So if it is 4 by 5, the probability 4 by 7, if it is 4 by 7, what should be the probability of getting it? P of P is nothing but 3 by 7. Understand? 3 by 7. If the probability of getting at least one contract is 2 by 3, at least one contract, whenever word problems are given, those problems to be converted to algebraic form is the art of the student. If you convert them to algebraic form, then it will be very comfortable to you. Solve the problem. At least you understand it like this: either electric contract or plumbing contract or both. At least one means what? At least one. Either electric or plumbing or both. At least, no, not exactly one. At least one. At least one means it may be 1 or 2 is given to be what? It is 2 upon 3. Now let us apply the formula P of E plus P of P minus P of E intersection P is equal to 2 by 3. What is P of E? It is 2 by 5. What is P of P? We have written that. It is non-occurrence given 4 by 7. Occurrence we have written 3 by 7 minus 2 by 3 is equal to P of E intersection P. What is the question? What is the probability that he will get both? He will get both. This is both electric and plumbing contract. Electric and plumbing contract. So in this case now, what is the LCM? You can simplify that. It is 7 5 35 into 3. It is 105, and it is 21 2 42 plus 1 35 1 15 3 is 45 minus it is 3 3 15 3 35 into 2 70. If you simplify this, you will get the answer. What should it be? 87 minus 70, 17 upon 105. Simple problem. But you must get the idea, because I said it's a mixed problems we are going to work out today. So I have taken the problem on addition theorem on probability. Addition theorem on probability. Okay, that's it. It's very simple. You can work out that. Go to the next problem. Suppose, it's an interesting problem. Suppose you have 10 keys and you wish to open a door and try the keys one at a time. From a bunch of 10 keys, you want to open the door key with this key randomly. I repeat the statement again. Suppose you have 10 keys and you wish to open a door and try the keys one at a time randomly until you open the door. Until you open the door. Only one of the key will open the door. Only one of the key will open the door. How many keys are in hand? 10 keys are in hand, and we are trying one by one. Then what are the questions based on that passage? The question you can see, if you eliminate each unsuccessful trials, then the probability that the door gets opened on 5th trial is given by. We're discarding every tree. That is, we tried one key and discarded, then 9 keys remain, then tried, discarded, then 8 keys remain. Like that, you are successful in the 5th trial. What is the probability of it? Next question. Next question based on the same. If you do not eliminate each unsuccessful trial from the remaining keys, then the probability that the door gets opened on the 5th trial is given by. What is the difference? In the first problem, you are discarding the unsuccessful keys so that the keys will be remaining. In the next problem, you are not discarding the keys.